How and where earthquakes happen. Earthquakes are one of the most destructive natural disasters. A single earthquake can kill thousands of people and cause millions of dollars in damage. Earthquakes are defined as movement of the ground that are caused by a sudden release of energy when rocks along a fault line move. Earthquakes usually occur when rocks under stress suddenly shift along a fault. A fault is a break in a body of rock along which one block slides relative to the other. Why earthquakes happen. The rocks along both sides of the fault are commonly pressed together tightly. Although the rocks may be under stress, friction prevents them from moving past each other. In this immobile state, the fault is said to be locked. Parts of the fault remain locked until the stress becomes so great that the rocks suddenly grind past each other. This slippage causes the trembling of the vibration of the earthquake. Elastic rebound. Geologists think that earthquakes are a result of elastic rebound. Elastic rebound is a sudden return of elastically deformed to rock to its undeformed shape. In this process, the rock on each side of the fault are moving slowly. If the fault is locked, stress in the rock is increased. When the rocks are stressed past the point at which they can maintain their integrity, they fracture. The rocks then separate at their weakest point and rebound, or spring back to the original shape. This process is shown in Figure 1. Two blocks of crust pressed against each other at a fault under stress, but do not move because friction holds them in place. The stress builds up at the fault, the crust deforms, the rock fractures and then snaps back to its original shape, which causes an earthquake. Anatomy of an earthquake. The location within the earth along the fault, which the first motion of the earthquake occurs, is called the focus. Plural is foci. The point of the Earth's focus directly above the focus is called the epicenter, as shown in Figure 2. Although the focus depth of an earthquakes vary, about 90% of the continental earthquakes have shallow focus. Earthquakes that have shallow foci take place within 70 kilometers of the Earth's surface. Earthquakes that have intermediate foci occur at depths between 70 kilometers and 300 kilometers. Earthquakes that have a deep foci take place at depths between 300 kilometers and 650 kilometers. Earthquakes that have deep foci usually occur in subduction zones and occur farther from the plate boundary than shallower earthquakes do. By the time the vibration from the earthquake that has an intermediate or deep focus reach the surface, much of their energy has dissipated. For this reason, earthquakes that usually cause most damage usually have shallow foci. Seismic waves. As rocks along the fault slip into new position, the rocks release energy in the form of vibrations called seismic waves. These waves travel outward in all directions from the focus through the surrounding rock. This wave action is similar to what happens when you drop a stone into a pool of still water and circular waves ripple out towards the center. Earthquakes generally produce two types of waves. Body waves are waves that travel through the body of the medium. Surface waves travel along the surface of the body rather than through the middle. Each type of wave travels at different speed and causes different movements in the earth. Body waves. Body waves can be placed into two main categories, P waves and S waves. P waves, also called primary waves or compression waves, are the fastest seismic waves and are also the first waves of the earthquake to be detected. P waves cause particulates to move in a back and forth direction that is parallel to the direction in which the waves are traveling, as shown in Figure 3. P waves can move through solids, liquids, and gases. The more rigid the material is, the faster the P wave travels through it. S waves, also called secondary waves or shear waves, are the second fastest seismic waves and arrive at detection sites after P waves. S waves cause particles of rocks to move in a side-to-side direction that is perpendicular to the direction in which the waves are traveling. Unlike P waves, however, S waves can travel through only solid material. Surface waves. Surface waves form from the motion along a shallow fault or from the conversion of energy when P waves and S waves reach Earth's surface. Although surface waves are the slowest moving Earth waves, they may cause the greatest damage during an earthquake. The type of waves that the two types of surface waves are love waves and Rayleigh waves. Love waves cause the rock to move side to side and perpendicular to the direction in which the waves is moving. Rayleigh waves cause the ground to move in elliptical or rolling motion. Seismic waves in the Earth's interior. Seismic waves are useful to scientists in exploring the Earth's interior. The composition of the material through which P waves and S waves travel affect the speed and direction of the waves. For example, P waves travel fastest through material that are very rigid and are not easily compressed. By studying the speed and direction of seismic waves, scientists can learn more about the makeup and structure of the Earth's interior. Earth's interior layers. In 1909, Andrea Mohorovic, a Croatian scientist, discovered that the speed of seismic waves increases abruptly at about 30 kilometers beneath the surface of continents. This increase in speed takes place because the mantle is denser than the crust. The location at which the speed of the waves increase marks the boundary between the crust and the mantle. The depth of the boundary varies from about 10 kilometers below the ocean to about 30 kilometers below continents. By studying the speed of seismic waves, scientists have the ability to locate boundaries between other internal layers of the Earth. The three main compositional layers of the Earth are the crust, the mantle, and the core. Earth is also composed of 5 mechanical layers: the lithosphere, the asthenosphere, the mesosphere, the outer core, the inner core. Shadow zones. The recordings of seismic waves around the world reveal shadow zones. Shadow zones are locations on the Earth's surface where no body waves form particular earthquakes can be detected. Shadow zones exist because the materials that make up the Earth's interior are not uniform in rigidity. When seismic waves travel through the materials of different rigidities, the speed of the waves change. The waves will also bend and change directions as they pass through different materials. As shown in Figure 4, a large S-wave shadow zone covers the side of the Earth that is opposite an earthquake. S-waves do not reach the S-wave shadow zone because they cannot pass through the liquid outer core. Although P waves can travel through all of the layers, the speed and the direction of the waves change as the waves pass through each layer. The waves bend in such a way that P wave shadow zones form. Earthquakes and plate tectonics. Earthquakes are a result of stress in the Earth's lithosphere. Most earthquakes occur in 3 main tectonic environments, as shown in Figure 5. These settings are generally located at or near tectonic plate boundaries where stress on the rock is greatest. Convergent oceanic environments. At convergent plate boundaries, plates move towards each other and collide. The plate that is denser subducts or sinks into the asthenosphere below the other plate. As the plates move, the overriding plate scrapes across the top of the subducting plate and earthquakes occur. Convergent oceanic boundaries can occur between 2 oceanic plates or between 1 oceanic plate and 1 continental plate. Divergent oceanic environments. At divergent plate boundaries that make up the mid-ocean ridges, plates are moving away from each other. Earthquakes occur along the mid-ocean ridge because the oceanic lithosphere is pulling away from both sides of each ridge. This spreading motion causes earthquakes along the ocean ridge. Continental environments. Earthquakes also occur at locations where 2 continental plates converge, diverge, or move horizontally in opposite directions. As the continental plates interact, the rocks surrounding the boundaries experience stress. The stress may cause mountains to form and also cause frequent earthquakes. Fault zones. At some plate boundaries, there are regions of numerous closely spaced faults called fault zones. Fault zones form at plate boundaries because of their intense stress that results when the plates separate, collide, subduct, or slide past each other. One such fault zone is the North uh, Anatolian Fault Zone, as shown in Figure 6, that extends almost the entire length of the country of Turkey, where the edge of the Arabian Plate pushes against the Eurasian Plate. The small Turkish microplate is squeezed westward when enough stress builds up. Movement occurs along one or more of the individual faults in the fault zone and sometimes causes major earthquakes. Earthquakes away from plate boundaries. Not all earthquakes result from movement along plate boundaries. The most widely felt series of earthquakes in the history of the United States did not occur near an active plate boundary. Instead, these earthquakes occurred in the middle of the continent, near New Madrid, Missouri, in 1811 and 1812. The vibrations from the earthquake that rocked New Madrid were so strong that they caused damage as far as South Carolina. It was not until the late 1970s that studies of the Mississippi River region revealed an ancient fault zone deep within the Earth's crust. This zone is thought to be part of a major fault zone in the North American plate. Scientists have determined that the fault formed at least 600 million years ago and that it was later buried under many layers of sedimentary rock.